My name is Thomas Padioleau. I work at Maison de la Simulation Laboratory in CEF near Paris. And I wanted to give you today some feedback about using Spack, again, for development as a software library developer, the Gyselalibxx library. So to give you some context, this started, we had this legacy Gyselalibxx application that is used in plasma physics for nuclear fusion to study core turbulence in tokamaks, and this is 30 years old. It is a 30 years old Fortran 90 code that was developed by one team at CA Cadarache in the south of France, mainly applied math scientists and physicists. And this was developed to be as easy as possible to install with only a few dependencies like LAPACK, OpenMP, MPI, and HDF5. These are usually available on clusters or easy to install on personal computers. And one last thing is that it was originally based on makefiles and later on refactored to use CMake. But with the arrival of the exascale and mainly GPUs, we needed to rework many aspects in the code, also some numerical aspects. And roughly 3 years ago, we decided to rewrite it from scratch in C++. And with a change of philosophy to be able to build more on top of domain expert libraries. And as a consequence, this introduced a larger number of dependencies, introducing heterogeneous languages mainly. So we don't see it directly in the code, but through Cocos, we have a dependency to CUDA, heap, or SQL, depending on what GPU vendor we are targeting. We also have some Fortran and Python dependencies. We tend to see that libraries have many compile options, and sometimes we need to rely on some specific options. And even though some of the dependencies can be found on the supercomputers by standard modules, there is always the question whether they have been built with the correct options. And some of these libraries, some of the dependencies that we now have are not even available on supercomputers. Admins sometimes just don't want to install them because they are not enough used by other users of the computer. So here is a non-exhaustive list of our direct dependencies. I will not list them. And so the question that came was to how to install these dependencies. So if we make a list of our wishes, we want, of course, an easy way to deploy our development environment. But we don't want only to deploy the binaries of the library of the Gyselalibxx. We need to be able to build, link, and run our. We need build, link, and run dependencies because we want to be able to modify the sources and rebuild and run our test that may have also some dependencies on plugins. And ideally, we would like non-specialists, so more math students or physicist students, to be able to install these dependencies and so that they are able to work and modify the source code of the library. Of course, as I mentioned it, we want some control over the compile options of our dependencies to be sure that they are correctly settled. And we want to be able to run on supercomputers. We tend to think that we should be relying on low-level softwares that are installed by admins to avoid some performance issues. And we want also to be able to, for development reasons, to be able to install these dependencies on personal computers, mainly on Linux, but recently we had a macOS user. We don't have yet a Windows user. So We thought about using Spack, and we successfully used it on different platforms. So we are currently using it with Spack environments views. We have different Spack environment files, one per typically per machine. So we have this Adastra supercomputer in France that is equipped with AMD GPUs. So we have one Spack environment for this machine. On this particular machine, the admins, and I think there will be a presentation by Etienne, they install the libraries on this machine using Spack. So we can chain with this Spack, they expose it to the users, and we can install the missing dependencies on this system. And we typically share one instance of Spack on the shared directory of the project. We also use it on a local cluster where we fully install all our dependencies. And on personal computer, that's also what I use in my daily environment for this library and others. But it was not without some difficulties. And then here are a list of them. The first one may have been tackled. So we are using Spack environments, and sometimes we needed to install a compiler. And it is doable, but it is not that easy. And even when we want to build the application, the library Gyselalibxx, and so we also need to load the compiler. And if we only load the environment, the compiler does not come with it. So we needed to work around this. It was not complicated, but. Then the second one is not also that difficult to tackle, but when we deploy the environment on a new machine, or when we update Spack, usually it never works the first time. There is always one of our dependencies that will break. Selecting a new version of one of the dependencies, and there is either a patch issue that shouldn't be applied anymore, one version of the dependency that does not support another version. Sometimes we had some side effects of, so we work on this local cluster, and some libraries are already installed on it. We share it with other users that are not using Spack. And some of these products installed on the host system can interfere with Spack. So as I said, we could use it on the supercomputer Adastra, but we reached almost the limit of the inodes on our quota on the project. We can still work on it, but I'm wondering what we will do when if we add a new dependency, and if we can still add request some an upgrade of the quota limit, but we are a bit concerned of this issue. And the main point is that we don't know yet how to work on other supercomputers that will not expose Spack. We will need to find another solution. I'm not sure. I don't know what's the status of finding external libraries for Spack. And the last point that I wanted to mention is that I feel like we are duplicating some logic when we need in CMake to expose our options, expose our dependencies, and we need to do that again in the Spack recipe. Some logics are very similar, and we have to be careful that when we update this logic, we do it also on the Spack recipe. We only maintain some Spack recipes, but if we add another package manager, we would have again to duplicate this logic. I don't know if there is a way to share this declaration of options or dependencies simpler. As a conclusion, we are still happy to use Spack. I think we think that it's a good solution, but it's still unclear to us how we will manage to have a more robust and portable solution on other supercomputers. And I think that's it for me. Thank you.
Thanks so much.